Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, by now you should be perfectly familiar with working with two or more objects of this type, or the possibilities of being able to join two different data frames together, or that of adding series to any already existing data frame, or simple and fast method to add data to a data frame. And of course, dear friends, today in this session, we will see some possible operations between two or more objects, whether they are data frame or simple series. So dear friends, actually the data frames like series can be used as operands in normally arithmetic operations. So however, when these two types of structured data are operated on each other, being equipped with indexing this characteristic must always be kept in mind during these operations. Okay, let me just start using two homogeneous data frames as operands. So we define two numerical data frames having the same structure. So one, it is of course the data frame 1, yeah, with the index ABCD and the columns also ABCD. Yeah, let me just define it randomly. And of course, let me just have one more data frame. So yeah, with the same structure, that is same index and column labels. So here we just go with the same index. So see here, ABCD and upper ABCD as the columns, of course. Okay, now with these two objects, it is possible to perform any arithmetic operations. For example, so they can simply be added together. Okay, so yeah, as very simple as like this. So in before that, just we want to know what is the exact value here. Okay, so 9065 in the A index and 8696 in the A index of data frame 2. So let me just make a simply adding together. So yeah, dear friends, observe here the A from the data frame 1, of course the 8 of data frame 2 has been added, and here we just get the value 17. Okay, so of course, yeah, every value whichever we just have, see, kindly just have a note of it. It is 0 and plus 6, we just get the value 6, and correspondingly 6 and 5. Here it is 9 and 6. Yeah, we just get 15 and 11. Of course, every values are just a simple adding together of data frame 1 and 2. And yeah, let me just put them within some arithmetic expressions also. Yeah, here we just go with, yeah, we want to have the subtractions of data frame 1 and twice the data frame 2. Okay, so of course the exact value of data frame 2 has to be multiplied by 2, and then it has to be subtracted. That is a difference. Find the difference between that exact resultant of data frame 2 and with the data frame 1. Of course, we just get some values that also being in negative 2. Okay, so let me just do some Boolean arithmetic operations. So kindly have a note of it. Either we want to identify data frame 1, the values in the data frame 1 is greater than data frame 2. So if we are just going to have a small comparison, so kindly have a note of it. 9 is greater than 8, 9 is greater than 8, of course it is true. And of course 0 is greater than 6, of course it is false. So yeah, of course we are just going to get it in the Boolean expression as a true or false. So kindly have a note of it. Yeah, so in all these cases, we observe the same behavior whether we are dealing with arithmetic expressions or Boolean expressions. So the calculations are applied by taking a single element of first data frame and the corresponding in the second data frame. So the elements are calculated one at a time, gradually up to the last element present in both the data frames. And that is the operations are gradually up to the last element, that is performed element by element, And yeah, in the end, the result is in the data frame with the same dimension and the same structure of the two operands. So two operands is data frame 1 and data frame 2. Okay, so far we saw two data frame with the same structure operator. That is between the first data frame and the second data frame. Okay, now yeah, the element correspond to each other and are used in the arithmetic and Boolean expression individually and then reported in the new resultant data frame. But what if the data frame didn't have an equivalent structure? So yeah, let me just see some two non-homogeneous data frame as operand. So kindly have a note of it. Here what we have, the column is, so kindly just observe the column A, B, C, D, and here the data frame 2, the column is B, C, D, E. Okay, so let me just execute it, and of course, so if we perform an arithmetic operation between the two of this type, okay, what we just get, so if we are making an arithmetic expression, so kindly observe, dear friend, the same thing which I just applied previous, now here for two non-homogeneous data frame, and yeah, data frame operands as data frame 1 and 2. So let I just make the arithmetic. So kindly have a note of it. We can see from the result that the calculations are made only for the column in the common between the two data frames. So yeah, of course we have BCD from data frame 1 and BCD from data frame 2. And of course we just get NAN in the column A of data frame 1, and from E, that is from data frame 2, we just get the NAN of the E column. Okay, so the columns that do not have a counterpart in the other data frame are in any cases added to the result but are valued with the NAN value. That is not a number, or you can just specify it as like a missing value. Okay, same goes for the lines. So if we perform some arithmetic operations between the two data frame that have only some labels in common, we are just going to make some operations. So kindly have a note of it, what we are here to do. So yeah, A, B, C, D here exact, but this exact index is B, C, D, E. Okay, so now let me just execute and find what would be the data frame 1 and data frame 2 arithmetic operation. So kindly just have a note of it here. Of course, the column are same, A, B, C, D here and A, B, C, D. But what about the index? So see here we have A, B, C, D, and to the data frame 2 it is B, C, D, E. Now let me just apply an arithmetic operations to this functionality. And yeah, here too only the rows that have a common labels between the two data frames are taken into consideration for the calculations. So whereas the unmatched rows in the other data frame are added to the result but valued with the NAN, which we just say is that is a missing value or not a number value. Okay, now let me just make one more functionality. See here, dear friends, if instead we take into consideration the arithmetic operations between a data frame and a series. So the element of the series will be calculated with corresponding element of each single row of the data frame. So yeah, for that, yeah, let me just go with one data frame here, and the next one, it is the series. Okay, let I just execute here. And dear friends, kindly just observe when we just do the operation between a data frame and a series. And yeah, let I execute here. So as we can see the result, yeah, the four element of the series are calculated. The four element of the series are calculated for each row of the data frame. each row of the data frame. So here too the labels of the index of the series will have to correspond with the labels of the column of the data frame. Otherwise there will be added in the result with the value. Okay, so yeah, let me just make that also here. So how this can happen? So this example, to this previous, we are having the same column. So kindly just observe. So here we are having ABCD, and towards this also an ABCD. So when we just make it, kindly just observe, the column here is ABCD, but towards the series it is BCDE. So when we just make it in that manner, what would be the resultant here? So observe, dear friend. Yeah, of course, they will be added in the result with the value of NaN. That is only the values which have the common labels between them. Between the data frame and the series have been done the operation. So otherwise it is with the NaN value, that is the missing value. Okay, now let me just move on to make a binary arithmetic method. Dear friends, in addition to the classic arithmetic operation that are expressed in the Python by using the symbols as like plus or minus or multiplication as like asterisk or slash, the Panda library provides a set of relative methods to be applied to data frame to perform binary operations. So by using the method as like plus, so see here, this is the exact plus. Of course, we are just going to make use of add, sub, mul for multiplication, div for division. Okay, so these methods, you can somehow manage the behavior of these operations, which is not possible with the corresponding arithmetic operator. So in fact, using these methods, you can choose whether to use the match on the label of index or on those of the columns, though the optional access parameter. Okay, so to see how these function works, okay, let's first create two data frame containing random integer here, and the two data frames do not have all corresponding index values, that is index labels. So while they will have the same column labels, so of course these column labels are same, but the index labels are different. So let me just create it first. Of course, here we just go, and we are just going to make the binary method and arithmetic operators. Okay, as we have seen the functions of binary operations corresponding to the arithmetic functionalities. If we want to add two data frames together, we are just going to use add function here. Okay, add method. So this is a method. Okay, so this method, what it just happens, this add method is exactly equivalent to the arithmetic sum between the two data frames. Of course, we are just going to have the addition of two data frames. Let I just have a small scroll above. So kindly just see here. Wherever we are having the common elements, of course, we are just getting the values, and the uncommon things, we are just getting the NaN value. The same goes for operations between the data frames and the series. Before that, let I just make the addition, how it happens. Both are the same. Both the values are the same thing. Okay, now let me just move on to the data frame and the series. In this case, dear friends, actually we will have consistent results only if the labels of the series correspondent to the labels of the column of the data frame to some extent. Okay, so here it is the series, and kindly observe ABCD is the exact index. And if I just want to make use of the add method and the plus method, I'm just going to apply both the things. So see here what we are going to have with the arithmetic and to the top binary values. Okay, so the exact result, how it is shown is, it is perfectly identical to the one which we are obtaining with both arithmetic operator and to the binary functionalities. Okay, dear friends. Now, let we just, so as we saw in the previous example here, yeah, the behavior between this arithmetic operator and to the corresponding method is identical. So, the values of the series are summed with the corresponding element on each row of the data frame. So, why use these method where when there are arithmetic operators that could do the same thing? So here, yeah, of course, I want to specify, yeah, using the methods for binary operations, you can vary their behavior depending on the positional or behavior onto that optional parameter specified. For an example, so let me just make use of that axis is equal to 1. Yeah, of course, you can vary the application of the operator by column or by row. So in fact, inserting the parameter axis, yeah, and specifying a series with the label in a manner consistent with other in the index of the data frame. Yeah, how we are just going to apply it. Yeah, kindly have a note of it here, dear friends. So this is what the series. And here we have done the axis is equal to 0. And yeah, it has been added here. And if I just make this one simple, so see here how it happens. So of course, with this axis is equal to 0, yeah, it is able to make it here with the index ABCD. So it is just getting it towards the addition of the data frame 1. So let me have a look of to the data frame 1 where it is. Yeah, I just scroll above here. Yeah, this is what the data frame 16676 and 7281. So let me have a view of it now. And yeah, so if we just make it 1 2 3 4, yeah, we just get the exact value of each and every elements. But when we just do it with an arithmetic, so how it happens? So yeah, this is what the main difference between an arithmetic operators and to the binary. So the value present within the series will be summed with the correspondent element present in the each column. So this is the difference behavior from the one which we just seen previously. So which differs significantly from that of the correspondent arithmetic operations. Okay, now, dear friends, another optional operators that can be used with this type of function is level. So, which will be very useful in the case of multi-index data frames. In this regard, yeah, we define a multi-index data frame with a 2 level for each dimension. That is 2 for the column and 2 for the rows. Okay, so yeah, here we just go with the multi-dimensional. So here the higher the value xy and the lower the value it is ab, and here the higher the first value it is xy, and towards the second level of value it is the lowercase ab. Okay, so yeah, let we just in addition we will assign the names to various level of indexing. So here we have assigned it, and now let we just make, so we can choose the indexing level. Okay, so indexing level in which to operate the operations. So adding the name of the indexing level. So see here, dear friends, here it is the indexing level. So adding the name of the indexing level to the optional level parameter. So for example, we can subtract the value of the series from the indices corresponding to the second indexing level of the columns. So in this case, if we just specify the level is equal to low, so we are just going to make it a subtraction of to the lower level. So yeah, what we just get it, kindly just observe. Yeah, dear friends, kindly just observe. Yeah, as we can see, the element of the series are 2 and corresponding to the label of the low level of the columns. So therefore, for each row of the data frame, the element of the series will operate twice One's for the grouped level X and one's for the grouped level Y. Okay, if we instead, let me just make it if we want to apply the operations onto that first level, yeah, let me just make it towards the level high. Okay, so let me make it how it happens. So see here, dear friends, in this case, the subtraction behavior is quite different rather than to the above. So kindly just observe, it is quite different. Both values under the X label are subtracted from the first level in the series. So while those from the Y label are subtracted from the second value. So here, of course, the exact result is different. So therefore it is different. So let we just make it some more operations here. So by combining the optional parameter level, okay, so yeah, with access, let me make use of it. Okay, so this time you can work on the row indexes acting to the second level. So row here, it is access is equal to 0 and the level is second level. So let me just see how it happens. Okay, so see here how it is much different. So when we just make use of rather making into the column, here we are just making it into that of indices, that is of row wise. Okay, yeah, now yeah, you can act at the first level also with the same indexes, that is access is equal to 0. So of course what we just get. So see how this multi-indexing is working it on. So things get more complex when we perform the previous operations between two data frames. So for example, if we use a data frame instead of the series containing in addition to the column and row indices of the multi-index data frame. Okay, so other further indexes, how it just working. So okay, let me just make use of the this exact data frame and see here what we have just made it. Yeah, index A is equal A and B and towards the column AB. So now let me just create this exact data frame and we consider a data frame that is in any case consistent with the label used at the various indexing levels. Okay, so here indexing levels, let me just make it here as axis is equal to 1 and level is equal to also 1. Okay, so now let me just execute here. Yeah, dear friends, kindly just observe in this case the data frame used as the second operator corresponds to the subset of the multi-indexed data frame. So whose values are added 4 times as many as they are corresponding subset in the multi-index. That is this X of this X which we just specified and towards the same X towards the Y in the column and next Y from the row and X towards the column and Y towards the row and yeah, Y towards the column. Okay, now let me just move on to the next functionality. It is operator, that is arithmetic operations between a subset of the same data frame. Okay, always remaining in the context of binary methods, a common operator is to use a subset of the original data frame. So as an operand to be applied in the calculation. So in fact, columns and rows of the data frames are often used as operator to be used for arithmetic calculation. So here, yeah, let extract a row and a column. Okay, so let me extract a row and a column from a data frame. Okay, so of course, what is the exact data frame? First of all, let me just make use of the data frame 1. And yeah, here it is the exact data frame. Now let me extract the rows and column from here. Okay, so this is what the one row, that is 0 indexes. So 6676, that is what here it's that. And next let me have a column. column A. Of course, here what we just have is 6732. That is the column A. Okay, so these subset that can be used as an operand in the operations on the same data frame. So if we just do, so kindly see here, dear friends, what we are applying. Yeah, we are making a multiplication operation. Okay, so we are making a multiplication operation, and of course you can just make it apply onto the column here and here towards the row. So kindly just observe what is the exact difference from each of the things. So here it is column towards the column, and yeah, the axis is equal to 0, and when you just make it towards the multiplication onto the row wise, yeah, here axis is equal to 1. Okay, now let me just make the same arithmetic operation between subset of different data frames, not the same data frame. Here let me just make it a different data frame. So here I'm just going to give two data frames. Okay, so let me just have the data frame 1 and the data frame 2 here. So yeah, let me just have the extraction of column of data frame 2A. Okay, so how this happening? So kindly just observe, dear friend. I'm just going to give here. So yeah, you are able to observe now, and yeah, I'm just going to extract. So depending on the labels here, I'm just going to extract the location, that is LOC, from the exact AB, the column. And yeah, the next one, it is just going to make the multiplication. So before first, let me extract here. What we have here, we are extracting a data frame. So this is what the subset from the data frame 1. And here we are just going to make it multiplication operations towards the column onto this data frame. Okay. And yeah, with the axis 0. And depending on the labels present in the subset indices, if there is no correspondence between the two operators, that is rows or that column, that may be valued with NaN. That is what here it is specified. Okay, so to complete the picture of methods that replace mathematical operators, there are something called relative methods. So relative operators. So yeah, here what with the exact operators, it would be as like the addition. Here we just specify RADD, and of course here one among the things I have just given is related to the division. So addition with R and subtractions with R, multiplications with R, and to the same divisions with R. Yeah, these operators are useful when a different value is produced depending on the order of the operands. So in fact, for an example, let me just make according to the division method. Okay, it is possible to express here with the division operations with the numerator data frame. Okay, so here if we just making it, so kindly observe. So this is what our data frame, and when we just make the division with 1, okay, so as like an numerator is the data frame and denominator division with 1, and kindly just observe, dear friends, if we just do a relative binary here, relative binary, I'm just specifying it RDIV. Okay, so let I execute here. So if the data frame must be replaced in the denominator, okay, so here we have to specify in the denominator, it will be possible to transcribe the mathematical operation in the form of method. So only by using RDIV. That is the simple thing. Okay, so in which the order of the operand is inverse compared to the previous phase. So previous it is df by 1, and of course here we just get 1 by df. So this is how we just get the exact resultant, dear friends. And yeah, regarding the data frame, as for the arithmetic operators, The same speech can be done with the Boolean operators also. So Boolean operator as like equal to, not equal to, greater than or less than, so on or there, applicable between two data frames objects. And yeah, let me just first create a small things with two data frames. And here it is randomly specified with 4x4 space shape of it. So here we just have a two data frame 1 and 2. So when we just apply, so when we just make an operations between that two data frame, that is Boolean operator. So by making a comparison between two data frames having the same structure, we expect as a result, so a data frame of Boolean values. So here when we just make it here, so kindly just observe, dear friends. So in which for each element we have the true value when the Boolean condition is satisfied and false when it is not. So let me execute here. Yeah, see here. So if it is, so data frame 1, so let me just have 6 is greater than 2. Yeah, it is true. So we just get it. And 4 is greater than 5. No, it is not. So we just get false. So that is what the exact, we have the true value when the Boolean condition is satisfied and the false when it is not. Okay, so as we have already seen previously, there is this Boolean condition or grade for a particular section. That is, for an example, if we want to select only the elements that meet that condition. So in that manner, if I just want to make here, so kindly just have a note of it, if it is meeting towards the condition. So how it happens? Yeah, of course. If it is not, we just get that NaN to be present. So kindly just observe towards the above. So wherever we just get the absolute functionalities, yeah, we just get it as like NaN. So wherever it is applicable. Okay, now like the arithmetic operators that have a corresponding binary method, for the Boolean operator, there are a whole series for corresponding method as like equal, not equal, greater than, less than, or less than equal to, greater than equal to. So let me these in the same way, let me just apply it as a Boolean operator. And here, yeah, we are just going to have the LT, that is less than method. Okay, so let I just first execute it. So see here, dear friends, as we can see, by applying the less than method, we get the same result as the corresponding that which we just have the above less than method. So see here how it happens. So here too, however, we find ourselves with a more flexible method than the corresponding Boolean operators and their behavior can. So therefore, we refine to work with complex data frame or complex such as data frames or series. And here too, the same rules explained in the previous sections that applies with the use of the optional access. That is also can be done. So, and level parameter can also be used. So particularly useful with multi-index data frame and between a data frame and a series. Yeah, that can also be applied, dear friend. And yeah, of course, dear friends, with this session, we conclude the most important features of the Pandas library. And I think we are known to what we are just have done with the features of the Pandas library, and you can operate on multiple data frame at the same time. And when you are dealing with a data frame with similar but not perfectly identical structure, you know how you now know how to merge them into a single structure by using merging, concatenating, and append method. And furthermore, you acquired important notations on how to use data frames or their subset as operands in arithmetic or Boolean expressions. And yeah, dear friends, I hope you found this video helpful and insightful. I have provided the code used in this video in this description. So kindly just make use of it and explore more. And if you want to take your learning to the next level and join us on the exciting journey, don't forget to hit the subscribe button and turn on the notification bell. Stay updated with the latest uploads. Thank you, dear friends. Happy learning.